Well, let's take a step back for a bit, because one explanation given for how the current coronavirus infected the human population is that it may have come from bats, possibly via another wild animal. Two scientific studies this month say that the way we are changing natural environments, such as rainforests, makes it more likely that viruses will jump from wild animals to humans. The most recent study, looking at virus spillover risk from the University of California, Davis, cautions that this has serious implications for global health. It says the risk of pandemic is connected to habitat loss, exploitation of wildlife, and species extinction. The study suggests infectious diseases emerging from wildlife are increasing faster than ever. The scientists conclude that beyond COVID-19, new thinking on land management, animal resources and the environment could help to reduce the risk of the next pandemic or even to prevent it altogether. Joining me from Davis, California, is the lead author of that study, Professor Kreuder Johnson, who's the director of the PREDICT project into emerging pandemic threats, also from California. We're joined by environmental scientist Laura Bloomfield, who has also published research this month looking at increased human contact with non-human primates caused by habitat fragmentation in Africa. Thank you to you both. Professor Kreuder Johnson, I'd like to start with you, please. You've said spillover of viruses from animals is a direct result of our actions involving wildlife and their habitat. So this pandemic is not a fluke then, it's humanity's fault.
Yes, in many ways, humans are sort of at the core of how we're increasing the risk of emerging infectious diseases from animals. We looked at a lot of animal viruses, in fact, all animal viruses that have crossed over to infect humans in the past over centuries. And we found some important trends that I think can really inform on what we need to expect in the future.
Such as?
So first of all, we found that spillover risk tends to scale up with increasing abundance of species. So we found, for example, domesticated species are incredibly abundant worldwide, and they've shared a lot of viruses with people. And we already knew that, so we were really interested in what's happening from wildlife, because the majority of emerging infectious diseases come from wild animals. And there are actually some wildlife species that have increased in abundance as well. They've adapted really well to the way humans have changed the world. And these species, mostly rats and mice, a few species of bats and primates, have also shared a lot of viruses with people. But most importantly, we learned a lot about the wildlife that have not adapted as well. In fact, more than 20% of mammals are endangered or threatened with extinction, and the vast majority are declining drastically in abundance. And it's the reason for these declines that shed a lot of light on what's underlying spillover and driving an increase in emerging infectious diseases.
Let's bring in Laura Bloomfield. You've done field work on this subject, spillover from wild animals to humans in Uganda. What did you learn?
Yeah, so all my work was conducted in Uganda, and what we found was that land use behaviors, the way in which people use their land by collecting small trees for construction or searching for food in the forest, as well as the degree of forest fragmentation near households, significantly increased the likelihood of physical contact events between wild primates and people.
You've said we're going to be very bad at being able to predict when and where the next infection is going to come from. Laura Bloomfield, why is that?
Well, I think we're looking at very complex systems. The world is changing in many ways. People's behaviors are responsive to that changing environment. And what I really focus on is trying to understand the context of that initial outbreak, are the factors that set the stage for a virus to pass from an animal into a person. And I believe that the best way for us to combat the future pandemic is to prevent infections going from animals into humans in the first place. So really mitigating and trying to intervene from humans and wild animals having these contact events.
Professor Kreuder Johnson, do we know enough about how this particular virus might have started?
We're still learning a lot about this virus, and that's very typical. Typically, we don't know what was the actual source of an emerging infectious disease until months or even sometimes years after a lot of research is done. We ideally detect the animal that's actually got this exact same virus, and that requires a lot of surveillance work. But we can say that more than likely some wildlife, especially bats, were involved as the actual reservoir. And based on our work, exploitation of wildlife through hunting, capture, and wildlife trade are especially high risk. And so live animals that are being sold in markets where animals and people mix and it's really crowded and there's a lot of close contact, that's sort of the perfect epidemiologic setting for viruses to jump between diverse species and eventually infect humans. And that's definitely the most plausible underlying cause of this outbreak. And then, yeah, go ahead.
I just want to put that to Laura. You've heard what Professor Kreuder Johnson was saying there and the plausible explanation for the outbreak. Is that what you're investigating as well, or sounds likely to you?
Yeah, I think that sounds right. And I think that the more fragmented animal landscapes become and the more probability and possibilities for people and wild animals to come into contact, we're creating those contexts in which multiple animals, domestic animals, and people can share viruses.
Back to Professor Kreuder Johnson, you've talked about deforestation being a cause of increased contact between humans and animals. Of course, that's a byproduct, that increased contact. As you said, wild animal markets, that is a deliberate choice by some people to put wild animals in contact with human beings. How much of a priority, when you look at all the factors, should the abolition of those kind of wildlife markets be?
I think we really need to take a very close look at the live animal wildlife trade, and that needs to be heavily regulated. And we need to do it in a very careful way that looks out for people's livelihoods, especially for some of the poorest people. But we should remember the people that are in contact with these live animals are the most oftentimes exposed themselves. I mean, they're routinely getting zoonotic diseases that transmit from those animals to them. It's only once in a while that one actually emerges that's human to human that then affects all of us, but they're affected more regularly than we realize.
Laura Bloomfield, the last question to you. Going through all of this once is bad enough. Having to do it again would be really difficult. What should the world do to prevent this from ever happening again?
Yeah, I think there's a lot of ways that we can support local economies and communities. And as Dr. Johnson was talking about, those are the communities that are most vulnerable to getting these infectious diseases. Creating more natural habitat corridors for wild animals and instituting buffer zones between wild animal and human habitats, I think will greatly decrease the likelihood of these contact events in the future. And I hope a lot of this research can inform policies that can help prevent the next pandemic.
Laura Bloomfield, environmental scientist at Stanford University, and Professor Christine Kreuder Johnson, University of California, Davis. Thank you both so much for that scientific explanation.